afternoon, everyone. My name is Felienne Hermans, and today I'm going to talk about Hedy, which is a gradual programming language I made for children. But before we're really going to dive into the technical details of Hedy, I want to take you back in time into my own personal history of teaching to program. We have to go back to the year 2013, which is a very, very long time ago, when I started to teach programming to children. And I don't have a background in teaching. Sometimes people think this because I made a programming language for children, but I actually didn't know that much about teaching, but I did know a lot about programming. So I thought, teaching children to program is not going to be hard, right? These were small children, like 10, 11, 12-year-olds. I thought, how hard can this be? How difficult can their questions be? This is going to be easy. I will just teach you programming. This will be totally fun. And then what happened is, not explicitly, but subconsciously, I started to think back to how I learned programming when I was a kid. So this is me, sitting behind my dad's very big computer, learning to program. But when I was a kid, so this is end of the 80s, early 90s, there were no programming lessons, right? No one taught me programming because no adults that I knew programming. So I never really sat through a programming lesson. No one taught me programming, but I did have this. I had a book that allegedly was going to teach me how to make games on my computer, which was good because I'm so old that there was no internet when I was young. Well, it existed, but I didn't have it at home. So I couldn't download any games. So I was like, yes, this will put games in my computer. But this wasn't a book teaching, in a sense. It didn't say, oh, this is a variable and this is a loop. If you would open the book, it would be this. So like printed out basic code. This is how old I am, right? There was not a floppy or a CD-ROM with the book. You just had to copy all these codes manually into the computer. And I didn't know any English before I knew any programming, so it didn't really make sense. But yeah, there was no internet, so what else was there to do? So I manually copied all of these things into the computer, and I sort of had an idea of what programming was, right? And this isn't just me. I saw some people like nodding in the audience. As a community, many people my age, like children of the 80s, have this history of learning to program, learning from a book by themselves, figuring a lot of stuff out. And this means that we, by and large, think that compilers are great teachers. Because compilers were our only teachers, right? It's like if you're a child and you don't have any toys, maybe you have like a plastic bag and you draw eyes on it. It's like, this is my stuffed animal. This is the relationship we have with compilers, right? Oh, it's our friend. It's not your friend, but yeah, there was no other friend. So this was definitely the way I internalized programming education. And what I did with those 10-year-olds, I was like, well, this will be fine. I just push them behind the computer and I give them printed out, well, not basic, but printed out codes. And they will learn magically because the compiler will tell them if they're wrong. Just to give you a little bit more context on how the programming club worked, initially we used Scratch. And this is Scratch, so this is a visual programming language. So you sort of click blocks together, and then you can make stuff happen. If you put these blocks there, then the cat, it turns around, and it changes color and makes a sound. At this stage, everything was still sort of fine. So kids were clicking blocks together, stuff was happening in the computer, and they were like, yeah, we're programming. So I was like, yeah, this is good. But then after a while, as children aged and as they had more programming lessons, they said, well, teacher, we want real programming. We want textual programming. We want to do the grown-up stuff. And it also really fits the age group, right? If you're 11, 12, especially in the Netherlands, where there's a cutoff between elementary school and high school at the age of 12, kids, they start to feel like, I'm old, I'm an adult, I'm going to the big high school, I want to do adult stuff, right? So they start to reject things that look like toys. This looks like a toy. It doesn't look like something that you can have a job with. So they said, teacher, we want to do grown-up programming. So I said, sure, children, no problem, that's fine. We're going to do Python. Python is known for its easy-to-use syntax and user-friendliness. This is Python. Because we're like, okay, well, this looks legit. Good. What do we do? Where's the cat? How do we make fun things? Fun things. Okay, well, you can do fun things in like half a year. What we're going to do now is print text on the screen. So it's like, okay, well, not sure if this is an advantage, but this is what you have to do. You have to do print, and then an opening bracket, and then a quotation mark, and then the text that you want to have on the screen, and then a closing quotation mark, and then the closing bracket. Okay, well, and then we have text on the screen. Good. Let's try this. But then, of course, this is really hard to get right? Some kids would do this. This is almost correct, but the P is an uppercase P, which you shouldn't do in Python. Makes sense, because usually you start a sentence with an uppercase. What does Python say? Name print is not defined. Why doesn't Python understand this? Right? Why? Why doesn't Python understand this? But this is still sort of okay. Even if you're a Dutch kid, then the error message is sort of understandable. In Dutch, we would say, print is niet gedefinieerd. Almost print is not defined. Okay. But here's another mistake. Now we forgot a closing bracket. What does Python say? Syntax error, unexpected EOF while parsing. Teacher, yes, child, what is parsing? Right? I don't want to explain now what parsing is and why this is a mistake. That's not the level that we're at, talking about why this is a mistake. But I have to, because Python confronts us with this. Here's another one. This is almost correct, right? This child is copying from the examples and doing it exactly correct. No, it's not exactly correct. There's a space there. This is literally an invisible mistake. And what does Python say? Does Python say, oh, fine, who cares about what? No. Indentation error, unexpected indent. Teacher, lesson 1, what is an indent? I don't want to talk about that right now, but I have to, because all of those concepts that we're not ready for, like parsing and indentation, sort of insert themselves into the classroom. So like, wow, this is hard. I didn't think it would be this hard. Maybe I was wrong. Maybe my childhood was a lie, and compilers are not actually great teachers. Maybe we need something slightly better, right? Because syntax is hard. We as experts, we think syntax is easy because we have practiced syntax a lot. So for us, it's not a burden anymore. But for a beginner, syntax is very, very hard. Something like this, which I would easily explain to a 10-year-old, right? So this is like for I in range, open brackets, for print I. So I was like, this is an easy thing to do. It's just repetition. It's just counting to 4. It's not even very exciting for a 10-year-old. Conceptually, it's not hard, repeating something, but syntactically, this is super hard. And some of the kids I found were so distracted by the syntax that we couldn't talk about the concepts. They couldn't see that this example is about repetition, because for them, the example was about getting the brackets right, getting the spaces right, getting the colon in the right place. So they were not really doing logical thinking. They were just hitting the keyboards until Python stopped being angry at them. So kids got really frustrated, and I got really frustrated as well. And at this point, sort of my scientific curiosity kicked in, and I thought, oh, I know nothing about teaching. I need to know more about teaching and understand why this is hard. And one of the things I learned about is a principle called cognitive load, which basically means if your brain is really full, focusing on details, you cannot reason about higher order thinking, right? This is, if we have to read, Dutch people or English people have to read a newspaper in Greek, right? You can maybe decipher every letter and maybe you can figure out a few words, but you can definitely not cognitively engage with an article in a language you don't know. If you want to know more about cognitive load, specifically the application of all sorts of cognitive theories to programming, I actually sort of went a bit overboard with exercising and figuring out things about learning, that I wrote a book called The Programmer's Brain. I actually, after this talk, have a book signing in the hall. So if you do want to buy the book, you can buy it today from me and get a signed copy. But as I said, I really dove into this topic because I thought, other people must have figured this out, right? Maybe I don't know how to teach programming, but other people in other fields must know how to teach other things, right? Many people know how to read. Many people know how to do math. How? How did they learn that? So how do other fields manage cognitive load? One of the things that I figured out, is not a surprise for people with a background in cognition or education, is that if we teach people languages, we do that slowly and gradually, right? Imagine you have a 5 or a 6-year-old that's learning to read, and they write, or learning to read and write, and they write this. Would you tell your 5-year-old, syntax error, floating A? Wrong! You would get very upset if a teacher would do that in school. Right? Wrong! It's not even a word! Boo. No, because that's not the level they're at, right? At a certain level, the level of a beginning writer, this is correct. This is like, yay, well done, child. And only later on they learn that, well, letters, those things you already master, they go in words, right? You can combine them, and then the sounds, cuts, cats, they make a word together, cool. Hey, here's a new rule. From now on, all words start with a capital letter. Kids are like, okay, practice, 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 right? This is also correct. And then gradually we add rules to natural language until kids master everything. And this is not just syntactic sugar, so to say, right? It's not just that we say you have to put a period at the end of a sentence because it looks nice. This is also the introduction of a concept. Because once we introduce a period to mark the end of a sentence, you can then make sentences that span multiple lines. Right? So initially for children, a sentence and a line, it's the same thing. That's just one concept. And later on, we split that into 2 different concepts where you can have sentences that span multiple lines and lines that contain multiple sentences. Like anything is possible once you can demark the beginning of a sentence and the start of a new sentence. So we gradually introduce syntax and also concepts to children if they learn language, and also if they learn math, and also if they learn other fields like physics. Rules gradually change. We don't teach everything at once. So like, hey, that makes sense. What do we do in programming education to manage cognitive load? Something like this. We give them all the concepts at once. If you first confront a child, or also an adult novice, with something like a for loop, you both teach them kind of complex syntax, like for, I, in, range. The range is fixed, but the I you may choose. The for you may choose, but the in is fixed. There's so many syntactic rules there that there's too much cognitive load, and some novices just cannot understand what you're trying to teach them. Because what I want to talk about is, hey, this one line is repeated 4 times. That's what I want to talk about. So rules gradually change in teaching. I was like, I can make a programming language that also does that, because I happen to have a PhD in software engineering and all the skills to build a programming language. So that's what I built. So I built Hedy, which is a gradual programming language that sort of mimics the way we teach languages. In the first level of Hedy, this is actually syntactic correct code that also runs. You just type print, and then you type whatever you want, and it prints. No brackets, no quotes, nothing, because I don't want to talk about those things now. And then later on, we add quotes in a later stage of learning. And then later on, we add brackets, because you don't need to add them in the beginning. You can do that later. And the same is true for repetition. First, when we introduce repetition to novices, we don't say for, I, in, range, blah, blah, blah. We just say repeat 4 times. And you can print everything on one line. You don't need to do indentation. You don't need to do a new line, because now we're talking about the concept. And later, we refine that. And of course, if you just repeat something 4 times, you don't have the full power, right? You cannot do 1, 2, 3, 4. You can just do 1, 1, 1, 1, but that's okay. Like it's okay that initially in learning, you cannot do very long sentences. You don't want to do that anyway. You don't want to do long sentences. You don't want to do 1, 2, 3, 4 initially. So talk is cheap, right? You want to see how this works in practice? Let me show you. So this is Hedy. As you see, it runs entirely in a browser, which is important because many schools and coding clubs cannot actually install anything on machines because they're not capable, or more often, they're not allowed to do anything. So it runs entirely in the browser. And as I said, you can just put print here and then hello something. So let me show you this actually works. Hello, GOTO Amsterdam. And I run the code and I just get output on the other side. It just works, right? So with this, kids can get used to the idea of programming. Oh, programming, it's, you put text on the one side and then output is shown on the other side. From the beginning, as I said, also one of the issues with Python was that it was just printing text, which can be a bit boring and doesn't really give a sense of what might be in the future. So what we also have from level 1 is that we also allow the user to ask for input and then repeat the input back. So we can use a command called ask, what is your name? And then it runs and they say, what is your name? Well, my name is Felienne. And then it says, hello, Felienne. So it's like magic. There is something like a variable and the value is stored somewhere, but the kid doesn't have to worry about that because we're just drawing their attention to the fact that you can print something, and also there's a thing called UI where you can input and output something. And as I said, we have multiple levels. So you see here, this is level 1, and whenever I'm ready, I can say, okay, I want to go to level 2 now. Now I'm in level 2, and in level 2 we introduce the idea of variables, right? We have something called a variable, called name and one age. So we say here, name is Hedy and age is 15, and then we can use the variables to print, and this just works, right? This is magic to us programmers. But wait, that one thing, name, it's a variable, and that next thing, but it is plain text, and you can just mix it. So we're like, this is weird. I feel, why is this the case, right? But for a learner, this makes sense because we're just focusing their attention on the idea that you can give a value, like name or 15, a name, and then you can use that name in multiple places. So just to show you, right, I mean, I understand you know this, but just to give you a sense of what the work is that a kid would have to do in Python to get this to work, right? Then you have to do this, and this, and this. And then as I said, for some kids, this is so much work that they get entirely distracted from the idea that I'm teaching. And of course, there's one issue here, actually, because the language is not so powerful, right? I can do something like this. Print, my name is name. And what I want to do is that it says my name is Hedy, but it doesn't do that. It says my Hedy is Hedy because any name is replaced, right? So now we have a problem, which is actually a learning opportunity. Because I can tell children, hey, wouldn't it be nice if we had a thing to tell the computer, but this is not name, the variable, this is name, the plain text. So this way we introduce the idea of quotes in a meaningful way. So Hedy goes all the way up to level 18, and in level 18, Hedy is a syntactically valid subset of Python. So slowly we move children to Python until we sort of draw away the curtain and say, ta-da, and now you're doing Python. So that's just a brief demo, and as I said, this just runs online, so if you want to check it out now or later with your children, you can just go to www.hedycode.com and try it out. It's entirely free to use. So maybe you're curious, like, how is this going? Because I started this project sort of right all the way at the beginning of the pandemic. I thought, would it be possible to build something like this, right? Because I knew this might be a solution to the problems I was seeing in the programming club, but A, I didn't know if it was like feasible to build something like this, and B, I didn't really know, like, will it be authentic enough for kids? Will it not look like a toy, like Scratch looks like a toy? So I built this and I put it on the internet and then sort of exploded and we got users and stuff. So it's going quite well, thank you for asking. One of the coolest things that happened to me this year was actually I woke up to this tweet where Guido van Rossum, who is the creator of Python, said, I discovered Hedy, a gradual programming language. It's a new idea how to teach programming to beginners. Very cool, yeah, thank you Guido van Rossum. That made me upgrade my Heroku plan to twice the monthly fee, but thank you for the promotion, that was cool. So it's sort of catching on, and not just with Guido, which is super cool, but also with schools. Like hundreds of schools worldwide are using Hedy to actually teach programming. So it's not just my programming club anymore, it's everywhere. So since the release of Hedy in early 2020, almost 2 million Hedy programs were created, out of which 700,000 are unique. Of course, many people create like print hello world, but there's also many, many different programs that have been created by kids around the world. And about 1 in 4 programs that we have in our database contains a syntactic error. And then you might think, wow, 25%. That's a lot. But yeah, well, it's not that much, actually. If you look at research into novice programming, then regular languages, just like Python or Java, have error rates around 50% for novice programmers. And for the weaker performing students, this goes up to 75%. So 3 out of 4 programs are not compiling for beginning programmers. And then you can imagine that's not productive failure, right? If 3 out of 4 programs gives you a syntax error, you're not like, oh, there's a mistake, let me just fix that one bracket and now everything's peachy, right? This is the I'm hitting the keyboards while crying type of learning, which is just not so very effective. So we're kind of happy with 25%, and we sort of set this goal of 50% really as an absolute threshold that we monitor. If there are levels that go over 50, then we definitely should change things. If you're curious, by the way, sometimes people ask me, like, why is Hedy named Hedy? Hedy is actually named after this lady, Hedy Lamarr, which was a famous inventor and also movie actress from the previous century. And she invented an algorithm called frequency hopping, which means that if, this is also in your Wi-Fi router, if a certain frequency is full, then the signal tries to hop to a different level. So I thought that's really nice because she's like a super cool inventor, role model. And also we hop over different levels whenever it's appropriate. So I thought that's really a cool person to name my language after. So maybe you're also curious that if we have so many users, do kids actually like Hedy? Is this like a solution to the problem? So one of the things that we did, because I'm still a scientist, is we ran a user study. So we did a study with 2 classes in the Netherlands with 39 children, and this was online because, well, it was the pandemic. So we gave them 12 online lessons to navigate them through the different levels of Hedy. And we tried to understand, like, what are the benefits of Hedy, what are the challenges, and how can we still make Hedy better? So the benefits, children said, oh, Hedy is really nice because it gets harder and harder, and it really becomes challenging later on, which we really think it's good. Because, of course, learning to program is challenging, but we don't want the challenge to be like a brick wall. We want it to gradually be a challenge. So that really works. And what children also appreciate is that they said, well, the levels are really a step-by-step guide. For some of you that might be familiar with Scratch, the visual language I showed you in the beginning, that Scratch doesn't really tell you what to do. Python doesn't really tell you what to do. So if you know what you want, you might be able to get there. But if you're a child that doesn't really know what programming is or what an end goal might be, you look at something like Scratch or you look at something like Python, and you're like, now what do I do? Right? So the levels really also tell children, this is something you can achieve at this level. And the teacher of this class, which I really, really like, this is really a comment we took to heart, the teacher said, when we used to do Python, some kids understood, but many kids didn't. And he said, with Hedy, all kids learn some programming. It's still the case that some kids learn more than other kids, but that's true in math as well, or in history. But he said, with Hedy, everyone learns a little bit. And I was like, yes, you know, that's what we want. In another study, by the way, we did, this was a female teacher with only female students. And she said also something I really liked. She said, Hedy really gives girls the confidence to learn programming. Because sadly, we know that girls come into programming classes with lower self-confidence. They think programming is hard. They think programming is not for them. Sometimes because they've been explicitly told that by friends or parents or older brothers, right? So because Hedy has these little steps, girls are like, oh, this is reasonable, right? This is reasonable. I can learn this. And they gain confidence as the levels increase. You can imagine that if you have very low confidence and you misplace one space and then you get an illegible error message, then you're like, yeah, you know, my dad was right. Programming isn't for girls, right? This is the sad reality of some girls in programming classes. But yeah, there are also still challenges, like Hedy is work in progress. So some of the kids in the experiment said that they still found it very, very challenging to actually remember the right commands, which is challenging. I sometimes forget how to do things. I used to program C#, and then I sort of moved to Python, and very often still, if I'm doing a loop, I'm still typing for each. And I'm like, no, stop, that's the wrong, like, remembering syntax is hard. And also kids said, of course, because of the nature of Hedy, yeah, you know, sometimes we learn something and then you change it. This is hard, this is unfair, which also is sometimes the way we teach, but that's, of course, definitely something we want to work on. We also ask kids, And these were 12-year-olds. I don't know if I mentioned that. So brugklasleeftijd in the Netherlands, the beginning of high schools. We also asked them, okay, if we could do one thing to make Hedy better, what would it be? Because I really believe as a scientist in participatory design, right? I want to design this with children because it's for them. So they said, yeah, we want to have better error messages. Your error messages are not clear. It's like, well, but I really tried my best on good error messages. Like, show me one you have issues with. So we got this one. So here you cannot put a comma. That's like for partial reasons, because a comma is also a list separator. So the kid said, this is really confusing. So why? Right? The code you entered is not valid Hedy code. There's a mistake on line 1, position 12. This is the exact position of the error. You typed a comma, but that's not allowed. This is good. Read this error to me. Like, why is it not clear to you, child? So the child goes, there's a mistake on line 1, position 12. You typed, but that is not allowed. It makes so much sense because there's a comma there. And what do we drill children in school? If there's a comma, you take a little pause. That's the thing you do if there's a comma. So they're like, you typed, but that is not allowed. Like, why am I not allowed to type? I type all the time. I'm like, yes, of course. It's such a bad idea to put a plain text character there. We put it in quotes, whereas at this level, kids don't even know that quotes mean literal text, because that's not even in the syntax of the language. So we changed that, actually. So now we have sentences in the error messages where we vocalize the names of things. So this is how this is a slightly more modern version of the interface. This is what it looks like now. So it says, you typed a comma, but that is not allowed, which makes so much more sense. And I think this is the type of thing you can only get from sitting, well, virtually then, because it was a pandemic, virtually next to a child. That's the only way that you can see that these type of things just don't make sense, because it looked very sensible to me in the beginning. What kids also said, and this surprised me a lot, they said, we want to have Dutch keywords. Right? So the whole interface from the beginning has always been multilingual. So all the explanation and even the error messages for Dutch children were presented in Dutch. But the keywords like print and ask and echo were always in English. And I thought, why, right? Dutch teenagers, they're supposed to know English very well. Why would this be necessary? But then again, I had to talk to myself. I'm like, yes, Hermans, but you think participatory design is very important. If this is what children are saying, you must build this. And of course, the real reason I didn't build this is because it's really hard. I didn't want to maintain multiple grammars in multiple different natural languages. I just wanted to have one grammar. I mean, I already had 18 levels, so 18 grammars. So I didn't want that. But yeah, it makes total sense. So even though initially I rejected this for cultural reasons, but also technical reasons, yeah, it was a thing that they wanted. So just let me show you what we did, because we did end up making everything in a different language. And I'm not going to show you the Dutch version, because, yeah, the Dutch version is basically the English version. Once we opened Pandora's box of different languages, we also had other languages that are non-Latin, and other languages that are right to left instead of left to right. So we built that, and just let me show you that we now also support Arabic, which is a lot of work, but totally worth it. So if I do this, and I run the code, then, well, I don't know Arabic, so I don't know what it says, but it must say something like, Hedy is 50, Hedy's name is Hedy, age is 15, Hedy is 15 years old. So the interesting thing, I think, is if you look at this, you're like, of course kids want localized keywords, right? For Dutch kids, maybe you're like, yeah, but if you speak Arabic, if you have a language that's so different from English, it must be localized, right? A teacher in Palestine, for example, where they speak Arabic, cannot say, type print with a P. The kid is like, what is a P? Where's a P on my keyboard, right? So the localization that we initially made for Dutch kids just makes a lot of sense for different languages as well. And as you see, we now support 25 different languages, and many of the languages also have their own keywords. So we have Italian keywords and Polish keywords and Farsi keywords. I don't even know all the languages that I hear. Oops. Yes. Where's my keynote? There it is. So just before we wrap up, I also want to talk a little bit about, geek out a little bit about all the technical things we had to do to make this work. So the basic idea of the architecture that we have is we have code, Hedy code, and we have a grammar that describes what the language of each level looks like. And then from code and an grammar, you can create an AST, an abstract syntax tree, and then we transpile the code to Python. Because Hedy and Python are sort of similar, it's relatively easy to make Hedy into Python. And in the higher levels, we don't even need to do that many things because it's almost already Python. We just have to add like a colon or a space somewhere. And we use an open source framework called Lark, which is a parser generator. So I didn't write the whole parser, you just have to write the grammars, and then it generates the parser for you. And one of the cool things, as I said, because it all lives in the browser, not for data collection reasons, but for reasons because it's easier for teachers, but we do have all the programs, and we do log all of the error messages. And if users make an account, which is optional, you don't have to do that, but if you do that, then we also ask you to, if you want to share that, get your age and gender and your location. So we can really do data-driven language design. We can see if a certain level goes 60, 70, 80% error rate, there's a mistake there. We have to fix something. But the challenge of that is, if you are changing something, for example, we inserted one new level 8 in between the old level 7 and old level 8, you also have all of the content, right? So at that point in time, we had 17 different languages. So you have to migrate all of the content and split everything out. So having users and having a lot of translations is really cool, but also presents a challenge opposing language-driven design. So this is, you see that this is like the pull request with all of the changes in all of the different languages, which is just a simple change, but it's still a lot of work. But what we also have is sort of fundamental challenges, because like managing 25 times 18 YAML files is like a practical thing. It's hard, but it's not inherently hard. But we also have interesting challenges, like we have code and a grammar and an AST. Like this is exactly what parser frameworks are made for. For one language like Python or C, and exactly one grammar, that's the type of thing that you do. Parser frameworks are just not written to have 18 different slight variations of the same language. So you have to do a lot of work. Right, so one of the interesting things, this is an actual program from our database. And here a kid is confused about what's going on in an interesting way. Because the first line is legal level 9 code. So for I in range 1 to 10. Right, you see it's slightly easier still than Python. So that's correct level 9 code. And this is correct level 7 code. So they are mixing level 9 and level 7 together, which is just such a reasonable thing to do, right? Because in the user study, kids said, well, it's so hard if things changed. Yeah, if you don't necessarily need access to the iterator, why wouldn't you just do repeat 10? This doesn't work. You get a mistake. Then the parser says, there's a mistake on line 2 at position 12. You typed 1, but that is not allowed. Yeah, this is sort of Python. It's slightly better, but no, this is not the actual issue. The actual issue is it's 2 different levels. But if this is not what parser frameworks are made for, this is certainly not what parser frameworks are made for, right? You have a piece of code, and it may or may not be one of these 18 different grammars, also in one of these 25 different languages. Can you please figure out which of the part goes where, and then you have this hybrid set of parse trees and then mix them together to still make Python. So this is like, no one ever had this problem, because why would you have 18 times 25 different grammars? Like, what are you doing? So the unique challenges, like the ease of use you want to give to the user, you sort of get it back, and then you have to do all of the technical work, which is, of course, cool, but also hard. So before we want to close off, I want to draw your attention to something. I am not a programmer. I am a professor that accidentally now manages this gigantic open source project. Right? So last year, I went on vacation for a week, not even a week, and I come back and there are like 21 pull requests waiting for me. And it's interesting because I made these slides a while back. Now I look at this, I'm like, 21 pull requests. That's a regular Tuesday. So it's even exploded from here. This is my GitHub history from last year, which is also an interesting visualization of my teaching load. So first I had 2 courses, and then I had 1 course, and then I had 0 courses. So then I was programming every day. But is this my job? I don't know if this is my job. And no one can tell me if this is my job. That's a sad thing. Like, you regular people, most of you, I assume, are programmers and not academics. You actually have someone like a boss, and that tells you what to do. So academics, we can sort of do things, which is, yay, that's great, because that allowed me to build Hedy. But it's also like, is this my job? Nobody knows. Nobody can tell me if I'm doing what I'm paid for. Right? Is this research? Some of the stuff we're doing, like the innovative grammar merging, is definitely research. We actually have a paper coming out in the Journal of Computer Languages where we talk about how to manage the complexity of a set of grammars and how to slightly adopt the normal form for describing grammars to actually manage this complexity. So that's research, but we also have a lot of stuff. It's like we have a nice user interface where teachers can upload a set of teachers and then we automatically generate accounts for the whole class. That's not really innovative software engineering, it's just programming work. So is this research? Maybe. Is this outreach? Like, part of your job as an academic is also to bring research to people? Part of this is that? Is it professional development? I definitely think that as someone that also teaches programming, not to children, also still that, but also to students in university, I've definitely become a better teacher of programming by programming every day. Right now, I confidently say to students, oh, you have a merge conflict. Oh, you just do some cherry picking. Oh, get this. These are things I abstractly knew before I started all this, but I didn't really have the practical skills, and I do now. But it's still sort of a challenge, and as I said, no one can really tell me if I'm doing my job well, which is it's sort of overwhelming in a sense. So in case you didn't catch it, Hedy is free and also open source. So if you want to contribute, you're more than welcome to. We support 20 languages. I was too lazy to update my slides in a proper way, so we now support 25 different languages. So one of the ways that you can also contribute, if you don't want to contribute to bug fixing, is you can help us translate. So some of the languages in our database are partly translated, but not entirely translated, because we also add new content. And then the translators don't always come back like every day to translate everything. So you can definitely help us with translation. But of course, if you want to, if you're looking for an open source project with impact on the world, then we're definitely happy to help. If you do want to do translations, you don't have to necessarily do that in GitHub. We have a web UI called WebLate, which is another open source project that we actually use, where you can translate everything like just in the browser, and it automatically generates a pull request from there. So that makes the threshold of translating a little bit lower, also for people that are maybe teachers that don't necessarily have the skills to do programming themselves. So that's it. That's everything I wanted to share. I think we have some time for questions. If you want to follow me, I'm on Twitter @Felienne, and you can also go to my website, felienne.com. If you want to know more about my book, you can go to felienne.com/book, or also, just for today, you can go to the booth outside of this lecture hall after. And if you want to know more about Hedy, well, you can go to www.hedycode.com to try it out, or you can go to felienne.com/Hedy, where you can find all the information about how to contribute as well.